When solving a system of linear equations, there are basically only three possibilities that can occur. The first possibility is if we have intersecting lines. And if we have intersecting lines, what we learn is that the equations of the lines must show different slopes. We only get one intersection, and so therefore there's only one solution of the system. And we say that it's a consistent system because it consists of a solution, and we say that the lines are independent. And what that means is I could not take the equation of one of the lines and multiply it by a number and get the other line. The second case that we could have is parallel lines. And if we have parallel lines, they'll have the same slope but different intercepts. And if we have parallel lines, we know that they will not intersect. And since they don't intersect, the system doesn't have a solution. We call that an inconsistent system, and we say that the lines are independent. And our third possibility is if we have coincident lines. And so these are the same line. So in a sense, if we take the previous examples where we had a blue line and a red line, in this graph I have just one purple line to show that I have the blue line and the red line right on top of each other. So these are coincident lines, and they have the same slope and the same intercepts. And since they're right on top of each other, they will intersect at infinitely many places, and so therefore there will be infinitely many solutions to the system. We say that it's a consistent system since it does have solutions, but these are dependent lines. And I'll show an example of what that means in just a moment. So now let's consider these exercises. Here we're asked, without graphing, determine the number of solutions and classify the system. And so my first system, here I have, so exercise 1, I have the system y is negative 2x minus 4, and 4x plus 2y is 9. And so this first line is already in a slope-intercept form, and so it has a slope m of negative 2, and the y-intercept is 0, negative 4. Let's consider the second equation here. 4x plus 2y equals 9. And what I will do here is I will solve for y. So let me subtract 4x. So 2y is negative 4x plus 9. And dividing through by 2, I see that y is negative 2x plus 9 halves. And so what I can see from this is that this second equation has a slope of negative 2, but its y-intercept is 0, 9 halves. And so since I have the same slope and different y-intercepts, that tells me that this system is parallel lines. And so this system would have no solution. I would say that this is an inconsistent system. And I would say that the lines are independent. Now let's look at the second exercise. Here we have 3x plus 2y equals 2, and negative 9x minus 6y is negative 6. So I'm going to go through a similar process, but for each of these equations. Let me take the first equation and solve for y. So I have 3x plus 2y is 2. Subtracting the 3x. 2y is negative 3x plus 2. And dividing by 2, y is negative 3 halves x plus 1. And now working with the second equation. Negative 9x minus 6y is negative 6. Adding 9x to both sides. Negative 6y is 9x minus 6, and dividing through by negative 6. Y equals negative 9 over 6. It reduces to negative 3 halves. So negative 3 halves x. Negative 6 divided by negative 6 is plus 1. So I see that these are the same line. These are coincident lines. They have the same slope and the same intercepts. So these are, determine the number of solutions. This has infinitely many solutions. This is a consistent system. These lines are dependent. And I say that this is dependent. Notice that I could take this first equation if I wanted to. If I took this first equation, and if I multiplied it, the whole thing, by -3, I get the second equation. The one line depends on the other. It's just a multiple of the other line. And so if we see something like that, we have a dependent system. It is consistent. There are infinitely many solutions. Now let's take this third system, excuse me. Notice the first equation here is exactly the same. So y, as in exercise 2. So y equals -3/2 x plus 1. And if I take the second equation, I can subtract 2x from both sides, and y is -2x plus 1. And so right away, I see that the slopes are different. Right? I see I have a slope m. On the first equation, m equals -3/2. On the second equation, slope m is -2. And since we have different slopes, that means that this system has one solution. It is consistent and independent.